Hello, my name is Joseph Busch. Today I will discuss application profiles as a framework for structuring information applications. The key argument is that application profiles are not usually treated as knowledge organization systems in themselves, but they contain two kinds of vocabularies that are central to knowledge organization: schema vocabularies and value vocabularies. I will also connect this argument to current questions about generative AI reliability and transparency. The talk moves from concepts to infrastructure and then to contemporary AI applications. I will begin by defining application profiles, then distinguish schema vocabularies from value vocabularies. I will then discuss how profiles are constructed, why documentation may be as important as interoperability, and finally, how the same framework can improve AI systems. The central claim is deliberately nuanced. Application profiles are containers or frameworks. They describe how to use existing standards for a particular application. But inside those profiles, we find two types of vocabularies: the schemas that define elements and the controlled vocabularies that standardize values. Those vocabularies are the knowledge organization components. These are the research questions and objectives of the paper. Firstly, what is the role of knowledge organization systems in application profiles? Secondly, in a resource description format environment, do we need application profiles at all? Thirdly, what is the role of KOS and application profiles in the AI environment? Three definitions frame the discussion. Hiri and Patel emphasize mixing and matching metadata schemas. Semick uses a data-centric semantic web vocabulary, while the W3C emphasizes use of base specifications for a community goal. Across the definitions, the common theme is structured reuse rather than creating an entirely new standard. Namespaces are more than technical labels. They identify authority, supply persistent identifiers, and define the data elements being reused. In application profiles, namespaces let communities assemble a profile from established vocabularies, such as Dublin Core or friend of a friend, rather than writing a local schema from scratch. The distinction is the core concept behind the paper. Schema vocabularies structure description, what fields exist, what they mean, and how they may be used. Value vocabularies, on the other hand, structure meaning, what terms should be used, what synonyms or broader terms exist, and how concepts are related. Both are necessary for reliable information applications. Metadata schemas are prescriptive. They tell us what kind of descriptive data should be captured and how those elements are structured. Dublin Core is the recurring example because it provides a widely used element set for resource description and has been central to application profile work. Controlled vocabularies address the language of description. They constrain variation so that systems and users do not scatter meaning across inconsistent labels. This is especially important in retrieval, where synonyms, hierarchy, and related terms can have measurable consequences for recall and precision. The paper distinguishes several forms of controlled vocabulary. Taxonomies organize hierarchical structure, thesauri adds synonym control and associative relations, authority files stabilize names, while ontologies provide richer formal semantics. These are not interchangeable, but each can play a role in an application profile. The Dublin Core application profile tradition makes profile construction concrete. A profile is not only a list of metadata fields. It includes requirements, a model of the domain, a description set, and guidance for usage and syntax. This is where the profile becomes a documentation practice. This figure visualizes how an application profile connects functional requirements, domain models, description sets, syntax guidelines, and usage guidance. The important point for this talk is that schemas and value vocabularies are embedded in broader design documentation framework. The original promise of application profiles is interoperability. If different systems follow the same profile, they can exchange information more easily. But the paper also emphasizes communities of practice. Profiles express community-specific requirements and practices, not merely technical constraints. The paper situates application profile work across several communities. LRMI addresses learning resources. DCAP and DCTAP address Dublin Core application design. ISKO2026 supports descriptions of knowledge organization systems, and Machine Actionable Data Management Plans, or DMPs, illustrate profile use in research data management. Neville and Mendez raise an important challenge. In an RDF environment, do we need application profiles at all? The paper's answer is pragmatic. Even if broad semantic interoperability can occur without a profile, profiles are still valuable because they document requirements and decisions for communities and implementers. This is one of the paper's strongest contributions. Application profiles are not only interoperability devices, they are scholarly and technical documentation infrastructure. They make assumptions explicit. They record why particular schema elements or vocabularies are used. That documentation is essential for transparency and reuse. The paper then brings the argument into the present AI context. Generative AI treats many kinds of content as processable data, but its outputs are variable and often opaque. Schema and value vocabularies can supply structure, terminology, and context that make AI applications more reliable and explainable. This figure shows a simple vocabulary-enhanced approach to prompting. Thesauri can add synonyms and quasi-synonyms. Taxonomies can broaden or narrow concepts. Metadata schemas can provide context, such as content type, geography, language, time, or process. The broader point is that vocabulary work can become part of the AI pipeline. Retrieval-augmented generation is presented as a way to make prompts more responsive to domain-specific questions. Knowledge graphs can support retrieval with equivalent terms and typed-related concepts. Vocabularies can be used before generation for retrieval and indexing, or after generation for annotation and verification. The paper cautions that RAG systems may rely on vector similarity without vocabulary-based indexing. That can be useful, but it is not the same as semantic control. A more reliable approach maps content to vocabularies and then uses those vocabularies to improve retrieval quality and explainability. For knowledge organization, the implication is that vocabulary work is not legacy infrastructure. It is directly relevant to AI, data exchange, and accountable systems. Application profiles can connect KOS theory with practical engineering and can serve as community knowledge artifacts. To conclude, Application profiles are best understood as structured documentation frameworks that integrate schema and value vocabularies. Their value lies not only in interoperability, but also in making requirements and design choices explicit. In the AI context, this framework can help move from opaque statistical generation toward more transparent, vocabulary-aware information applications. This reference slide provides an abbreviated bibliography for the presentation. I invite discussion and point you back to the standards and scholarly sources that anchor the argument. Thank you.